Welcome to Get Your FRQ On. This question is from the 2005 B exam. It's question 1, and it is calculator active. In the question stem, we have two functions, f and g, and a region R, which is defined to be the region bounded by the two functions. A graph of this is provided, and it appears as if the two functions intersect at x equals 0 and some positive number. In part A of the question, we are asked to find the area of the region R. So in order to find the region R and its area, we have to know our bounds of integration. So we have to know where these two functions actually do intersect. Now, because it's a calculator active question, we can find those points of intersection using our calculator. So we take our two functions, 1 plus sine of 2x, set that equal to e to the x over 2, find out where they intersect. They intersect at x equals 0 and x equals 1.13569. At this point, I'm going to take the liberty of calling that last value capital B just for brevity's sake. I am going to use that letter B later. So the region R would have area defined by the integral from 0 to b of my upper function, which is 1 plus sine 2x, minus my lower function, e to the x over 2. It's a calculator active question, so use your calculator to do it. And that area is 0.429. In part B of the question, we are asked to find the volume when R is revolved around the x-axis. Now, because we're revolving around the x-axis, we're going to integrate with respect to x. And we need to consider which function is furthest away from the x-axis and which function is closest to the x-axis, because this is going to be a washer method volume. So our big radius is going to be f of x, and our small radius is g of x. So our volume of revolution would be given by pi times the integral from 0 to b of my big radius squared, 1 plus sine of 2x squared, minus my small radius squared, which is e to the x over 2 squared. And again, it's a calculator active question, so there's no reason not to let your calculator calculate the volume here. The volume is 4.267. In part C of the question, we are asked to find the volume of the solid if the cross sections perpendicular to x are semicircles with the diameter in the region R. All right, so this one's a little tricky because semicircles, all right, diameters in R, area of a circle, we typically think radius. So we have to define or somehow figure out our radius. Well, our radius is going to be 1/2 the diameter. Right? But because the diameter is in R, the diameter at any given cross-section is the difference between these two functions, 1 plus sine of 2x minus e to the x over 2. I want half of that as my radius, so I'm going to define a radius function, r of x, to be 1/2 of that difference. Then the cross-sectional area, excuse me, could be given by a function a of x, which is pi halves times that radius squared. Keep in mind we are only looking at semicircles here, so we do have to divide by 2. Excuse me. And now I can integrate from 0 to b my area function, a of x dx. And again, it's a calculator active question, so let the calculator do the work. That volume is 0.078 cubic units.